Hello viewers, welcome back. In this video, we are going to talk about classification of PDE, which is with linear, non-linear, semi-linear, and quasi-linear partial differential equation. So first of all, what do we call a PDE? A PDE is a partial differential equation. So it's a type of differential equation in which the dependent variable depend on more than independent variable. Dependent variable of z or u can depend on x, y. So that is what we call a partial differential equation. So in this one, how can we now classify? We have classification of them: linear PDE, we have non-linear PDE, we have semi-linear PDE, and quasi-linear PDE. So how do we classify them? Linear PDE. A linear PDE is a linear partial differential equation. A PDE is said to be linear if the partial derivative occur only in the first degree and are not multiplied. When we talk about a linear PDE again, it's said to be a linear if the partial derivative occur only in the first degree and are not multiplied. Remember what we call a degree. Degree is the power to the highest order in a what? In an equation. That's what we call a degree, the highest power. So z or u is a dependent variable. Then partial derivative can be the z over the s. Yes, because if you differentiate z, you're going to have with respect to x, you're going to have partial z over what? Partial x. Or you differentiate u with respect to x, you're going to have partial u over partial s or the u over the s. So that's what this statement implies, which is xy, which is the partial independent variable. X and y are the independent variable. That z is the what? Dependent variable. Z depend on what? X and y. Why x and y is independent variable, they do not depend on anything. Z only depend on x or y. Whenever we differentiate z with respect to x, we are going to have a partial z over partial s. That's why we have a what? Partial derivative can be this. If it is u as well, we are going to have the partial u over partial s or the u over the s as what? Partial derivative can be this. So example, the square z over the x square plus the square z over the y square minus 2s is equal to s square is an example of a linear PDE. Why this one is a linear PDE? Let us study the example 1. It is linear PDE according to what? Definition. And whenever you want to classify linear PDE, other PDE, how will you want to know it? To know example, and if you want to study it very very well, you have to what? You have to be on main focus on the degree. The degree, how are you going to get degree to this? Degree is the power to the what? To the highest order partial derivative. That is the highest order partial derivative. This is a partial derivative, this is a partial derivative, this is a what? Derivative. And this is what? This is what is equal to s square. So you can say that this one, the order of this one is what? 2. That is, you differentiate this one 2 times. You differentiate z with respect to s, we now differentiate z again. That x is x with respect to s again. We have order of 2. So order of 2, you look the power. You can say that we don't have any power here. It means it implies that the power is also 1. Here is also what? The power is also 1 here. So it means this one is order 1. This is a degree 1, order 2, order 2. So the definition said is said to be linear if the partial derivative occur only in the first degree. You can see that the degree of the only first degree, the degree of this partial differential equation is what? 1. This one is also 1. So it will classify this one as what? Is a linear partial differential equation. You can see the second example. There's z over the s, there's z over the y minus z. So let us check the order. The degree, the order is 1, the order is 1. So it means you can see that this one is 1, this one is 1. The degree to this is what? 1. The degree of this is what? 1. So it must not exceed 1. That is, must not exceed more than what? More than 1. That is, only occur in the first degree and are not multiplied. You can see that they are not multiplied here. What is multiplying here? Nothing. The order of this, the degree of this is 1. What is multiplying that order partial derivative? We don't have anything is here. It's just 1. 1 multiply this, we are going to have this. What is multiplying this again? We don't have coefficient of any value that is multiplying this. And same thing as this, same thing as this, then same thing as this, same thing as this. That is, the degree of this is 1, the degree of this one is 1. Is a linear PDE. Whenever your partial derivative, the order, the degree is 1, you call them what? A linear partial differential equation. And it is not multiply because there's no coefficient here. What's the coefficient that's multiplying the z over the s? Nothing. The z over the y is nothing, it's just 1. 1 multiply this will give you this. So second classification of PDE, non-linear PDE, is the partial differential equation in which the dependent variable and its partial derivative occur more than 1 degree and are multiplied. It means otherwise, if you have a linear PDE, otherwise of a linear PDE will give us our non-linear PDE. That is the opposite of linear PDE will give us what? Non-linear PDE. What does it mean? It means that whenever you have an equation, it means the degree must be 2. And the degree must be 2 and it must be multiplied. The degree must be 2 and sometimes they multiply together. That is, they have a coefficient that multiplies. So the example 1, we have the z all over the s square. We have plus log z xyz. You cannot classify this one as a linear PDE. Why? Because the power to this partial derivative is what? Is 2. So we cannot classify this one as a linear PDE. Why? Because the power is not 1. Suppose our power here is 1, or we don't have anything here, we call it a linear PDE. But non-linear means the power, that is the degree, must be what? Must be more than 1 degree. That is 2 upward. Must be what? That which is 2. More than 1 degree. You can see that degree is 2. Another one example again. Second example. Sin the z over the s, the z over the s plus the z over the y minus exponential x. You can see that the z over the x, what will come to your mind first is that you say this one is a linear PDE, which is not linear PDE. Why is it now a non-linear PDE? I explained that a non-linear PDE, the partial derivative must be what? The degree must be more than 1, that is 2 upward. So you can see that this one, the degree of this one is 1, the degree of this partial derivative is 1. But once you multiply, if you use this one to open this one, you're going to have the square z over the s square. That makes it to be what? That makes it to be what? A non-linear PDE. You can see that this sin ds all over the s is embedded in a bracket. Once you open this bracket by multiplying the z over the s with this, you're going to have what? You're going to have what? You're going to have the square z all over what? The s square. That is the order of is 2. Then it's still what? The degree is also what? Is also 1. The degree is also what? Also 1. Because we are having sine, that is, and we are having the z over there is multiplied with this. So the degree is 1. The degree is 1. But in some textbook, the degree is 1. We all know that the degree is 1. But if I tell you that the degree is undefined, you will not believe. Because whenever we have a sine, anything trigonometry that is multiplying a partial derivative, we classify that degree is what? Undefined. Whenever you have a trigonometry, sine, cos, tan, multiplying a partial derivative, the degree is what? The degree is undefined. So there's no degree that you have to, there's no degree here. We don't have a degree here. We have order, the others are 1, like order 1, but there's no degree here. But why do we now call it a non-linear PDE? Because there's a what? There's a what? Is have a coefficient that is multiplied. That is, if you use, what do we have? The z over the s having what? Sin s. You can see that the coefficient of the z over the s is a sin x. You have a value that is what? You have a trigonometry that is what? That is multiplying the partial derivative, which is the z over the s. That's why we say is a what? Non-linear PDE. According to the what? According to what they are multiplied. Now, let's just go to number 3. Semi-linear PDE. A PDE said is semi-linear if its highest order derivatives appear linearly and their coefficients are function of the independent variable x and y. So let us check this example. The z over the s plus the z over the y raised power of 2 is equal to the square z over the s dy. So what do we call a semi-linear? Just read very very well. This second statement, if it is highest order derivative, what is the highest order? So it means order, it means how many times do you differentiate? So it means the highest derivative appear linearly. You can see that the z over the y is there. We differentiate 1 z with respect to y. What do you have here? We differentiate z with respect to x. When we get the value, we now differentiate z with respect to what? Respect to y. How many times do you differentiate? You differentiate 2 times. It means the highest order here is 2. So the order of this is 2. The order of this one is 1. But that highest order must be what? Linearly. That is the power to that highest order must be what? Must be 1. Which is what? It means here is 1. So whenever we have an highest order derivative appear linearly, which is whenever we have it, it is linearly, that is the power is what? Is 1. You can say there's no, it means the power here is 1. It is what? Semi-linear PDE. And also, their coefficients are function of the independent variable. That is, sometimes we are going to have a coefficient x or y. X can multiply this sometimes, or y can multiply this. You can say that the coefficient of this is we are differentiating with respect to x, with respect to y. So independent variable x and y. So this one is a semi-linear PDE. Another example again, the z over the s open bracket 1 plus into the z over the y. If you use this one to open this bracket, you are going to have this. You're going to have the z all over the x plus, use this one to open this one, you're going to have the square z all over what? The s, the y. So if I now ask now, what is the order of this? The order of this is what? The order of this is 2. The order of this is 2. The order of this is 1. The order of this is 2. It means the order is 2. So order of this is 2. But let us check if that highest order, which is 2, is it linear or not? So is it like the power, is it linear or not? That is it the power? Is it 1 or more than 1? You can see that this order, the highest order 2 here is what? The order of this one is 2. The partial derivative, the degree is what? The degree is what? The degree is what? 1. Also this one, the degree is what? 1. You can see that this is semi-linear PDE. So we classify them according to their definition. So in some textbook, you may find that they are going to write it as what? Notation. Remember that we have talked about notation whenever when I said our p is the z over the s, our y is what? The z over the y. Then we have r, s, and t. Now, if you want to classify this one is the z over the s. The notation for this is p. P plus this one is what? Q square is equal to what? Having a what? Having a function of what? Independent variable, that is x and y. So it means pq. So whenever we have the square z over the s, the y, it means we are differentiating x with respect to what? With respect to y. So we are going to have x. That's what? P plus QQ is equal to S. In some textbook, they write it like this, and in some places you can find it like this. So they are trying to tell you that the highest order of this is what? The highest order of this is what? Is 2, and the degree is what? 1, which is what? Linearly. So let us consider this as well. This is on the z. We have all this bracket. The z over the s is p plus the square z over the s the y, which is what? X. Then is equal to what? The square y all over the y, the square z over what? The y square, which is what? R square. I can take this one to here. Sorry, q square. You can see it's also the same. So this is a semi-linear PDE. So final one, quasi-linear PDE. A PDE is quasi-linear if it is highest order derivative appear linearly, but their coefficients can be function of both the independent variable, the dependent variable. That one is also related to semi-linear. The only difference between semi-linear and quasi-linear is that in semi-linear, the highest order derivative appear linearly, and it must be function of what? The independent variable x and y. But in quasi, it will be a function of independent variable, also what? Dependent variable. Now look up. Let us check this example. The z over the s plus the z over the y. The coefficient of the z over the s is z. Z is a dependent variable. The coefficient of the z over the y is what? X, independent variable. You can see that we are having dependent variable multiplying by the partial derivative. Then we are having what? Independent variable multiplying by what? Partial derivative. Whenever you have an equation in a form of this, we call it a what? A quasi-linear PDE. Let us check the second example. The z over the y minus 2x, the square z over what? The y square is equal to what? Z square. The z over the y. Let us check the order, the highest order. What is the order of this? The highest order here is 2, order 2. And it is what? It is linear. Multiply by what? The independent variable. So the coefficient is what? 2x. S is what? Independent variable. So that's why we classify this one as what? A, a quasi-linear PDE. So I cannot say this one is a semi-linear PDE. Why? Because if I say the highest order here is what? Is 2, and the degree is linearly, which is 1. But it's multiplied by what? It's multiplied by what? 2x. It's multiplied by what? 2x. So it's multiplied by what? 2x, which indicate that what? Which indicate that it must not be multiplied. It must only be multiplied by individual variable x and y. So you can see this one is z. You can see this one as what? X. We cannot classify this one as a semi-linear PDE. Why? Because it is multiplied by what? Dependent variable as well as what? Independent variable. But if it is only independent variable that is multiplied and the degree is what? The degree is linearly, you can see it's a semi-linearly. But whenever we have an equation that is multiplying with what? In which the dependent variable, partial derivative is multiplying by the independent, also and dependent variable. It means what? It is a quasi-linear PDE. But if it is not dependent variable, it's only independent variable. And the highest order, the degree is what? The degree of the highest order is linearly. You classify them as what? Semi-linear PDE. This is just about linear, non-linear, semi-linear, and what. So in our next video, we are going to classify some examples of semi-linear PDE given to us. So thanks for watching.